Hello everyone, let's look at week number 67 and task number 1. The task is about number combinations. You've got two numbers m and n. Write a script to print all possible combinations of n numbers from the list 1, 2, 3 up to m. Every combination should be sorted. For example, 2 and 3 is a valid combination while 3 and 4 is not. And there's an example, so the numbers are 5 and 2, so 5 is the maximum number, here it is, and 2 is basically the length of this item. And for the number 1 on the first position, we've got 4 combinations. For number like 3, for example, the first element which can be in the second position is 4, which is the minimum element which is more than 3. And for the number 4, there's only one combination, 4 and 5. Seems to be okay, and let's look at the solutions in the Raku programming language. And the first solution we'll look at is the solution from Chenif, solution number 1, and it's just basically one line of code. There's the main function which takes from the command line two integers m and n, and what we are going to do next we are going to print. We start with range 1 to and including m, and then we are calling this combinations method on it. What this method is doing, let's look at the documentation. For example, it is important to understand that there's like the list on which this method is called. It can be either a method or just a subroutine, but nevertheless there's a list as the first argument, and the second argument here, for example, is the number of elements in the output sequence, right? Output items. So it generates a sequence, like this is a sequence, and each element of this sequence is two numbers in this case, because here is 2. Okay, that's clear. So n, that's what we have in the definition of the task, and then we are filtering this using grep, and the block to filter is, so it takes each item. Basically, it's this item, right? Like A and B here. And we are flattening, make it flat. I'm not sure if we really need to make it flat, but I believe yes. And after that, this reduction operator is applied. And inside this reduction operator, there's this less operator. So basically, we will filter out only those elements which have the items in increasing order, right? Okay, and then we will print it. So I believe we can run this program, Raku share 1. Why is it Perl 6, by the way? And right, yes, so we have to, so 1, 2, 1, 3, 1, 4, and 5, 2, 3, 4, 5, 3, 4, 3, 5, and 4 and 5. Right, so it works, and right, so this is a very useful method. Actually, I forgot about this method. I didn't use it in my solution. So then Donald Hunter, Raku number 1, let's look at the solution. Yes, it's a bit bigger, and there's one example of how we're calling this function. So m and width is 96. What is width? So I believe like the width of the screen to output the output. Okay, so yeah, basically these are the combinations. It started exactly with the same combinations method call for the range 1m and with the width n, generate the combinations, then format each combination. So then for each of them we just preparing a text string, because so yeah, there are too many different brackets and braces and curly braces. So first of all, these parentheses are for the map method. Then there are parentheses to have the block of code, and inside this block of code there are double quotes for a string, and inside the string we have, well, basically some text with square brackets, but inside those square brackets we have another block of code which is interpolated within this string in double quotes, and there inside it we have we're calling method join on the element which was passed by map, and we join those elements using this character, using the comma. Notice the difference that this method map is called as a regular method using parentheses, and this join is called with the colon syntax, so there are no parentheses, but that's a valid method call in Raku. Okay, so we've got these combinations formatted somewhere, and we didn't filter anything yet, right? So the next step is to do something, I don't know yet, but let's look. So Perl line, what is Perl line? So it's width, those 96, integer divided by the maximum from, so we take all the combinations and we have the length, and we have the length basically of this string, right? We increment it by 2, I believe, to include those square brackets, right? And right, so like there are Perl line combinations which we can print per line to get 96 in the output, right? Then we take these combinations, original combinations, without filtering, right? Then we, oh my god, we split into n per line rota. So basically what this rota is doing, so it takes like, well, it's just, it takes every, I believe, every per line. So yeah, so like for example there are 100 here and per line is 10, then this rota will give us 10 different lists with 10 items in each, right? So, well, actually there's it's supply and it returns the supply, but never mind. For example, is there any, yeah, like this, from 3 to 9, rota 3 gives us these, so 3, 4, 5, 3 numbers, these 3, and then 3 more, 6, 7, 8, right? And yeah, if you want like the last elements also to be included in the output, just use this partial key, and you see, so the last item is a bit shorter, but never mind. Going back here, so we split these combinations into partial is here, into pieces. Those pieces can be printed within 96 characters. Actually it looks like 96 excluding this comma. Then we are mapping them, so yeah, we are mapping them to join them by comma, join items on same line. I wonder why we cannot just call join without any map. Yes, because so here we have like in my example 10 by 10, so we have 10 elements, and inside each line we have 10 elements inside each line, and we have 10 lines, and this map will join, will put comma on a single line, and we have to repeat it for each line, right? And then we, yes, now we join lines using this, and basically, yeah, we print it in some square brackets, but I don't understand where this filtering comes from. It looks like it doesn't come from anywhere. Donald Hunter, so Raku, Donald Hunter, Raku, show number 1, Perl 6. So it's you see it's for 8 and 3, and 1 to 3, but it works, right? But that works. So can I just change it to be the same as the integers given in the example, which are 5 and 2, and run it again? So this gives wow, so basically it gives us exactly the same output as was in the example of the task. 1, 2, 3, 4, 5, 2, 3, 4, 5, 3, 4, 5, 4, 4. Wow, but how does it work? I want this solution like to be examined. Let's save it in like one Raku, yes, and make it 5 and 2. So I want to examine all those. So let's just dump these combinations Raku. Visual Studio Code doesn't know about Raku yet. Combinations. Right. Raku 1. Where am I? I believe it's not 68, but never mind. Right. So the combinations 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4. Basically, that's interesting. So then I want to go back and see the first solution that we look at, and I wonder why do we need the combinations here, right? Let's, the first solution saved in file Raku number 2, Perl 6. And so we know that this prints what we want. Then what if we will do it like this? So tell me the difference. 5 and 2. Haha, there's no difference. I see. Yeah. So there's no need actually to call grep. But how is it possible? What the combination is? Why is it so? Returns a sequence with all of combinations. What is off? It's the second argument, the length of the invocant list. Off can be a numeric range, in which case combinations, it's not our case, right? Otherwise is cursed to int, right? This is our case. Above, there are 3 possible ways to combine the 2 items lists from the original list, which is what we receive in the output. See permutations if you want permutations instead of combinations. With range, not for us. Negative, not for us. Some implementations, right? So basically, as we see here, for example, and actually even here, so it's AB, AC, BC, but never, for example, BA or CA or CB, right? So it's already. So if we'll do it like this, let's run it again. Right, so 1, 2, 3, 4, 5, 2, 3, 4, 5, 3, 4, 5, and 45. So we don't actually need to append a grep here, right? Nice. The only thing that the output is different, but that's not what I want to focus on because the solution is correct. Right, okay, very interesting. So we make a solution shorter and we learn something about the combinations method. Let's go back to the list of solutions and look at Luca's solution. Luca Ferrari gave us this. So there's again main function. It takes 2 numbers, both are integers, and this colon indicates that we are expecting named parameters in the command line, like -m equals something, and this something is something between 2 and 10. Wow, I wonder why is it like opposite direction. The upper edge is first and the left edge is last, with the default number 5. And the second number, which is less than the first number, and the default is 2. So notice that this equals 2 is not a part of the where clause. It's just the default value of the variable, of the argument. Okay, so combinations, found combinations, and we are finding these combinations by appending them to this combinations list. But what we are appending, we're appending some digits, and the digits are so this smile, cat smile or whatever. So 4, we have 1 repeated n times, m repeated n times. Basically what this is, let's just look, and you see, so it's int. I want to see, so for example, Raku 1 repeated 5 is so, and if we'll give it, okay, let's just look at what this prints. So my m is 5, my n is 2, and then this one gives us this from 11 till 55. Why is it 11? So this construct is simple, so it's a range that exclude the first and the last elements, right? So it's like 12, 13, and up to 54. For example, we can do it like, we can prove this like that, right? 54, and the first one is 12. But I wonder, why do we need this? So how do we get that 11 from here? So n is 5, right? So if we like do it like this, right? But why is it 11 then? I don't understand. Why is it 55? What's that? So okay, so print it like this, right? It's 11 because n is 2. We repeat it, right? Okay, so then we will call int. It will be okay. So yeah, now I understand it. So the first number is 1, the second number is 5, and each repeating like n times. Basically, probably we don't need these. Maybe we need it because I don't know how the range operator will work if you have strings on either sides. Those strings are integers, right? But they are strings, so probably it will be incorrect, right? So we can just put plus in front of these parentheses. Okay, so this basically repeats the number, and so the sequence is from 11 till 55. Okay, I don't understand how it's going to work yet. Then so we are taking this current number. We saw that the first number is 12 and last is 54. Then we split it into digits using the comb method. So there are digits, and we skip, we do not push anything to the result if the number of elements in this array is not 2. Let's stick with this 2. We skip it if the number is more than original number, right? Okay. The number of no, if there are digits which are so if there are digits in these digits, so basically in this number, if there are digits in this number which exceed m, or if so these digits, it contains the numbers, if sorted digits is not and the next question is like unique digits is not inside this array. So right, so these sorted digits should be. What happens if you compare two arrays which contain, so this is a list and this is another list, 2 3 4, so this is false. And what if, for example, 1 2 3 1 2 3 4 5, this is false. 1 2 3, yeah, obviously 1 2 3 will be okay, but 1 2 3 3 2 3, okay, 2 3 1, it's false. So basically it gives us if the sorted array is the same array as itself, and finally if the unique array is the same as itself. Basically when we call unique, we remove all the duplicates if they happen to be there, to happen, for example, like for number 33 or 44. And then we push the combinations, and then we join, we sort again, and we print this comma separated, right? So I believe we will have the output numbers 12 13 14 15 23 24 and so on, right? well, right, I don't know yet, but let's just run this Lucas solution. Raku number 1. They are space separated, and I wonder where does this space come from, because push digits combinations sort. So these are the combinations which are the elements of the combinations right array. We're joining them with comma. Here is the comma, here is the comma, and yeah, so there are 2 elements, and okay, yeah, that's the task for homework, to understand why this space here. I believe this is something coming from say, which prints, but never mind. What is really interesting, so the solution is completely different from the previous solutions, and so you are you're generating some sequence. The difficult thing is to estimate this. Basically, yeah, now I understand it. So if we let's look at the example. And so what we have here, so basically, yeah, we start with 1 1 1 2, so it's basically the numbers, right? With 2 digits we can generate these numbers 11 12 13 and up to 55. And what is 11 and what is 55? Both of them are basically the repetitions of the first digit, of the lowest digit, which is 1, and of the maximum digit, which is 5. Right, now I understand this. Okay, very, very, very unexpected solution, very unusual and interesting solution, and it gives us the correct result. Okay, Mark Anderson, Raku solution number 1. Here it is. Okay, so yeah, unfortunately there's nothing to look at here because we already seen mostly exactly the same. Maybe there's this one, so the condition, the where clause, restriction for the input numbers, and no, actually, yeah, I was wrong. There is something to look at, because in the previous solutions and also in other weeks, we saw that like where condition only restricts the current parameters. For example, m where m is like more than something, n where n is something. But here we see that the where condition being applied to the second parameter, but it actually also checks the first parameter, and basically it restricts everything. We saw something like where a more than b, right? But this one is basically just give the whole solution for the whole line. Really, I think, useful approach. And then these combinations, and unlike the first solution, there are no parentheses here. It's just the column method call. But nevertheless, let's run this Mark. How do you spell Mark Anderson? Mark Anderson Raku 1 5 and 2. I will not run this with other digits because we've seen the result here, for example. Right, good. It works, and it works correctly. Node Raku 1. Yeah, exactly the same solution. Let's say so this number combinations. You see, so yeah, so this is the pure combination, the pure result of just calling the combinations without filtering anything, and we print the result by using the same method, by calling it as a method on the result of this function. Actually, yeah, we can make it a bit simpler if we remove this return keyword and maybe even this semicolon, because for such one-line functions it's not that necessary, but it's a matter of style of the author. Shahid. So the solution is just one-liner. I will not run it because we've seen this already a few times. Simon Proctor. So here we again have this unsigned integer, the restrictions for the input value. I wonder why this comma is here. It's not a really common thing that I've seen in other solutions in the Perl Weekly challenges in Raku. And then we what do we do? Yes, so you see, so this line starts with a dot, which means that this join method is called on some topic variable. We have to find where this topic variable was set, and it obviously was set by this for loop. And inside a for loop, we just use the combination, the result of the combinations method, and loop over them, and join them with a comma, and then we say we're printing them. Maybe let's run Raku, Simon, Proctor, Raku, chair 1, Raku number like 5 and 2. So this prints is the list like this, but again the output format is not that important for these challenges, I believe, and it works. Okay, next, Perl and Raku solutions. Again, we will only looking at Raku solutions, and Arne has these again, so combinations. Then map, we've seen this somewhere earlier, very similar thing. So we join this, and then we join. So yeah, basically, all these map join things are preparing the output so that it looks like exactly like in the description of the task, including those spaces and absence of the spaces here, for example, and the space here. And yeah, this is what I just mentioned earlier, where is applied to each of the parameters. And maybe another thing to notice that Arne is a fan of using this unit sub instruction. So basically the whole file after this unit sub is the body of the main function. Raku, Arne, Raku 1. Right, 5 and 2. Right, okay, Athanasius, let's see what we have here. It should be really interesting, and it begins with a very thorough explanation of what the arguments can be. It's unsigned integer, it's defined, it's more than 0, and then again the combinations, right? So this is the thing we saw many times already. Wow, this is what I actually couldn't expect. I mean, probably I've never seen this. So on the right side, so this is after the error we've got, yeah, well, the anonymous block, but you can treat this as just a loop variable, but actually this is the argument of the function, the parameter of the function of this anonymous function. So and there's a type restriction here. This is really interesting thing. So you restrict, I don't know actually why you need it, because we already know what this thing will give us. So it will give us something, and so why should we again like demand that this is list? But okay, so we have these com lists, and we join it with comma, then no, we join it a bit later, but first we're trying to print this inside square brackets, right? I wouldn't use sprint here, it's just string interpolation which can be used, and we saw a few examples even with blocks inside string interpolations. And then we just put it into strings. So this string is really nice because we just see what we are collecting there. And after that we just count the number of this, the length of this array. And why do we need this? Where is this? Yeah, so here is the output. Wow, yeah, interesting. So it also checks which form of the verb to be to use here in the output, and then we'll just join it. Yeah, and the standard thing for usage. Let us run this. Raku, Athanasius Raku, challenge number 1. Right, we have to 5 and the numbers. There are two unique two combinations of the integers 1 to 5, and the output is exactly what is required. Really interesting. So once again, the things to note here is this, and maybe this one. I'm not sure that we can do it a bit like simpler, but that's a good thing to think about. Yeah, you always have to think about what you will print in the output. Colin Crane, Raku number 1. Yes, so the only difference here that we didn't see is just the name of the variables. It's max and alums, and yeah, we're just saying this for but let's run this because so I believe Raku, Colin Crane, Raku. Yeah, so we have these spaces, and remember your homework somewhere earlier we have to explain why there are some spaces, and here is basically the answer. Right, Jaldar, Raku. Right, so yeah, so also an interesting construction just to get these the values from the args global variable. Global, is it called global or yeah, but it's homework again for you. Then these combinations, then we map, we do something with, you see, so this q and curly braces instead of just quotes, here as well, yeah, it's a lot of curly braces, but then we see that we can print the combinations, I believe, exactly in the same style that was requested in the task. Right, Javier, Raku. Right, there are two versions of the main function. Notice that there's no word sub here. So I would use it, but yeah, if it's not required, you don't have to use it. So it's multi-main, and the empty main. So interesting, really interesting. So what it's said here is that default parameters are 5 and 2. So instead of just providing default values here, we provide the function which takes no parameters and just calls another function with some default values. Nice. Yeah, and there's an intermediate variable, the array data, for the range, and then combinations n. Right. Okay. Lauren Rosenfield, Raku number 1. Right. The same. Right. This week is really, this task of this week is really like the only solution with combinations. I will have you, we'll show you an exception. Yeah, we saw an exception already, but here we have, okay, so the main function, default 5, default 2. There are some where restrictions, both are more than positive integers, and number combinations, again, these parameters. I believe these where clauses are not really necessary because we take the arguments already filtered out, right? Already they are already good, but yeah, we don't know how this function is called in a general case. An error message is printed if something is wrong with the arguments. And then again, sprint. I don't know why people are using sprintf, because, well, yeah, it's fine, but sprintf is a bit like C style thing, and Perl style thing, or Raku stylish style thing is just string interpolation. You don't need to print use printf and all those percent characters. But maybe it's a good thing because you immediately see what's there inside. But now with string interpolation, you also see what's going on inside. Nevertheless, so the string here is this string, which is again combinations mapped to get the characters, to get all those commas and square brackets, and then join in, then outer square brackets, right? Okay, let's run this Raku Mohammed Raku 1 Raku. Yeah, that's right. I would be surprised it would not work. Definitely it works. And Ulrike, yes. Yeah. So yeah, maybe just to to give some comments if we need any. There are some spaces here and here which I would not expect. It's like kind of French punctuation, like the comma preceded by a space. But yeah, nevertheless it works, I hope. And finally, my solution is a bit different because I didn't use combinations. Yeah, I knew about that, but I completely forgot. So yeah, so my solution looks really ugly. So what I'm doing here, I'm repeating this list twice from 1 to m, so it's basically 2 lists, and then I cross product of them using this reduction operator with the cross operator inside it. Then I sort. So yeah, this one is just to make it is separate in separate lines. So this is the so-called unspace. So we cannot. We have to have it, because without that the program doesn't work, because Raku does not expect any space here if you want to apply this operator. So we sort every item, so this thing applies the next operation to each and every element of this whatever it is, sequence or list or whatever. Then we so then we only find unique elements, because this will give us, I believe, not only unique things. And these as parameter named parameters have this whatever code block, so we treat the items as strings. Then we grab and we're trying to find all those elements where the number of unique elements is the number of the requested widths of each element. Then we sort again using the string representation. And then we've saw this like 5 times at least, all those commas and stuff, and again separate between the items and these things with spaces. Yeah, and here is the output. Yeah, so this is really ugly solution. So dot combinations actually is doing all the work. And that's it from this week 67, the number combinations task number 1. So basically we saw more or less similar solutions with combinations method. There was one solution which was really outstanding, and yeah, that's it. So don't forget that there are 2 tasks this week, so there's another separate video about the second task. And yeah, keep safe and stay tuned. Goodbye.